So in this section, let's look into comparison test. If we have two positive series, that's non-negative, two positive series, AN and BN. If we want to compare BN with AN, if BN converges, that means AN converges. If BN diverges, then AN diverges. If we want to compare this with this series. Now before we start the comparison test, let's talk about P series. P series. A P series is a series of this form. P series is a series of this form. Which is also called a generalized harmonic series. A generalized harmonic series. Now this series 1 over n is per p. If p is greater than 1, that means this series converges. But if p is less than or equal to 1, that means this series diverges. Also, geometric series. The geometric series is a series of this form, positive series of this form, or now if R, this R is less than 1, then the series converges. But if R is greater than or equal to 1, then the series diverges. Now look at this series here. First one, n over n squared plus 1. Now this series behaves like a P series because this is n raised power 2, just like n raised power p. So we need to compare this series with this. We need to compare this series with this is n. The highest variable here is n, that's n raised power 1, that's n. And the variable here is what? N raised power 2. Just take n raised power 2, which is equal to 1 over n raised power 1. Clearly, we know that n over n squared plus 1 is less than or equal to 1 over n. Now, this series behaves like this series. So that means we want to compare this series with this series here. Let's compare with 1 over n raised power 1. Now, the 1 here is like p. And the p is what? Is equal to 1. So if p is less than or equal to 1, diverges. P here is what? Is 1. This what? Diverges. Because p is equal to 1. Then if this diverges, this what? Is what? Also what? Diverges. Diverge. Because the series you compare with diverges, then this series also what? Diverge. And second one, 1 over 4 root n is the same thing as 1 over n raised by 1 over 4. Now the p here is raised by is 1 over 4. That's n raised by what? 1 over 4. That's n raised by what? P. Now the p is 1 over 4 because it behaves like this series, like a p series, n raised by p, and p is what? 1 over 4, which is what? Less than 1, diverges. So that means this series also what? Diverge. Now 3 times 2 raised to power n, just like a r raised to power n this is what? A geometric series. A r raised to power n. And this is the r here that is raised to power what? N. The r is equal to 2, which is greater than what? 1. Diverges. This is a geometric series and it what? Diverge. Geometric series and it's diverge. Now also, D now you see that here we have 1 over n, just like the same thing as 1 over n raised to power 1. Then we have 2 raised to power n. Here we have a p series. Here we have what? A geometric series. If we have a p series and a geometric series together, it's better for us to compare it with what? A geometric series, not a p series. Now, this is the same thing as this. This is 1 over n dot 1 over 2 raised to power n. Because for any value of n, if n is 1 or 5 or 6 or minus 1, because you get 1 here. So for any value of n, if n is 5, this becomes what? 1. So 1 raised to power n is still what? Is still 1. 1 raised to power 5 is still what? Is still 1. For any given number, 1 raised to power, that number is what? Is still 1. So this is like a r raised to power n. Now the r here is what? Is 1 over 2, which is raised to power n. A r raised to power n. Now the r is 1 over 2, which is what? 0.5. So 0.5 is less than 1. That means the series converges. Because 0.5 is less than 1. But if you compare with p series, that's 1. Less than or equal to 1, diverges. That's a mistake. Compare with what? The geometric series. Now the next one, E. To infinity, 3 raised to power n over 2 raised to power n plus n. This is like what? A geometric series is like a p series. So compare with what? Another geometric series. If we have a p series and a geometric series together. So this behaves like this. This series behaves like this series. 3 over 2 all raised to power n. This is 3 raised to power n and this is 2 raised to power n. So this is a r raised to power n. The r is what? 3 over 2, which is 1.5. So 1.5, if r is 1.5, 1.5 is greater than or equal to 1. That's what? Diverges. R is 1.5, greater than or equal to 1. That's what? Diverges. And F, this series here, behaves like this series. This series behaves like this series. This is n squared plus 1. The highest here is what? Is n squared all over. The highest here is what? N raised to power 4. So that means this series behaves like this series. And clearly, this is less than or equal to this. So, this is the same thing as from 1 to infinity, 1 over n raised to power 2. So this series, you have to compare with this. It behaves like this. Now, this is a p series. N raised to power p. Now, p here is what? 2, which is greater than 1. So, p greater than 1 converges. That's how to test for the convergence or divergence of p series and geometric series using comparison test.